3 minutes to try this warm up. And again, it related to after we go through this. Well, I want you to make sure you did it correctly. All right, so everybody should have tried this. This relates back to yesterday's lesson. So what we learned and talked about yesterday was graphing square root functions and identifying the transformations based on the equations, and then being able to identify key features like domain and range. So what we did first yesterday was to put the parent function on our graph. So I'm going to do that first here as well. I'm going to darken my axes. They're kind of hard to see here. All right. And so as a reminder, your parent function started at 0, 0, and then you went 1, 1, 4, 2, 9, 3, and then it continues beyond that. But those were the main 4 points that we plotted yesterday. So we said it starts here at the origin, goes through 1, 1, 4, 2, and 9, 3. Okay, so that's what we're starting with. Okay, then you should have identified your A, H, and K. So what was the A value here? Positive 2. What does that do to our graph? What type of transformation does that affect? A vertical stretch. That's exactly right. So A being greater than 1 means it's a vertical stretch. If that A was less than 1, it would be, or between 0 and 1, I should say, it would be a vertical compression. If it was negative, it would make the graph reflect. But since it's positive, there's no reflection, okay? And since it's greater than 1, it's a vertical stretch. Okay. And then you needed to identify your H. What is H here? Good. It's the opposite of what you see in there with X. So it's -4. And remember, your H is your horizontal shift. So since this came out negative, that is a shift left 4. Okay, and then your K is what's added or subtracted on the outside. So in this case, it was the -3, which means that K does up or down translation. So this is down 3. Now in yesterday's notes, we did examples with shifts left and right and up and down, and we even did a reflection, but we did not have an example that had a stretch or compression. Now we did stretches and compressions last unit with quadratics, but in yesterday's notes about square roots, there wasn't a stretch or compression. That's why I wanted to be sure and put this one here. It's a little different if you go over to your graph to try to just move the points like we did yesterday. I can do that with my vertex. I can say, okay, it's going to go left 4, down 3. So there's my new vertex. And I didn't even actually have to count that from the vertex. I know based on HK, remember your HK is your vertex. So I knew there was going to be a point at -4, -3. Now, there's no stretch for that first point because your stretch is from your vertex. So with the following points, when I go to move them, so for instance, this second point here, if I go to move it, let me just see if I can color code this for you. So if I go to move this point, I'm going to go left 4, down 3, but then I need to vertically stretch. So instead of being here, see it's up 1 unit from the vertex, I need to stretch that by 2. So I need to be up 2 units from the vertex. So it needs to be here. Okay. And then if I do that with the next point, this one here, I'm going to go 1, 2, 3, 4 left, 1, 2, 3 down. That means I am 2 above my vertex, but I need to stretch vertically. I need to double that. So I need to go up another 2. So it's going to place it here. Okay, and then if I do that with another point, okay, with this last one, if I go over 1, 2, 3, 4, and then down 1, 2, 3, I'm up 3 from that vertex point. I need to double that, so I need to go up 3 more. So that's going to put the point here. Exactly. A lot of people don't get it when we do it that way. That's what I wanted somebody to be like, huh? Because it's definitely harder to do it that way. We were doing our transformations that way yesterday by just taking each individual point and shifting them. But it's really hard to see the stretch and know how much you're supposed to stretch by doing it that way. Okay, so the easier method is to take your table, your parent function table that we had here at the beginning, and say, okay, my A says I am multiplying by 2. So I'm going to take those Y values and multiply by 2. So instead of 1, this is now 2. Instead of 2, that is 4, and that becomes 6. I multiplied all of those times 2, right? Because from my vertex, I go over, because horizontally, X, and then I go up vertically, Y. So I was going over 1, up 1 from my vertex, but this time I need to go over 1, up 2. So you can see from where we plotted the vertex, if we go over 1, up 2, that's where this point is. Or if I go over 4, up 4 from my vertex, that's where this point is. Or if I go over 9, up 6 from my vertex, that's where this point is. Is that a little easier to plot the points that way using the table? I think so. I think the majority of students think so. So there's the new graph in green there. And I know it's kind of hard to tell. Let me see if you can see it a little better if I zoom in on it. But we can definitely tell that it has shifted left and down. So it had the horizontal shift left 4, down 3. But you can also see the green graph is increasing a little steeper than that black one. Y'all agree? Okay, it's not quite as flat as the black one. That's because there was a vertical stretch. Okay, another way to think of that vertical stretch. Okay, ooh, there we go. When you look at the change from the vertex to that very next point, if it's helpful to you to remember slope, like I know this is not a line, so we don't technically have a slope, okay, but when you're plotting that next point, slope is rise over run, isn't it? So from the vertex to that very next point, we rise 2, run 1. So that's a slope of 2 technically. The rise over run is 2, isn't it? And our A value was 2. So for instance, you're not going to do that with all of these other points, but just from that very first vertex to that very first point, that's normally over 1, up 1. Okay, so it normally has a slope of 1. You're changing that to 2 because A is 2. So now you rise 2, run 1, or over 1, up 2, whichever way you prefer to think of that. So what's the domain of this new function? Yeah, it's the farthest left it goes is -4 because our H shifted the graph left 4. So our domain was shifted left 4. Okay, remember in the ALEKS assignment, there's no infinity symbol on the questions that ask for domain, so you can't use interval notation. You have to use the inequality notation. So remember, you would write this as x is greater than or equal to -4, because it's everything from -4 and to the right. And then for the range, what would the range be here? -3 to infinity. And again, because our k affects our range. Okay, so our graph was shifted down. So the lowest point on the graph is down here at -3. Okay, the furthest left point was over here at -4. In inequality notation, that would be y is greater than or equal to -3. Now, I know it also asks for the intercepts here. I can see that this graph crosses both the x and the y axis, right? But the only one that has an actual point plotted on there, so it's got integer values, the only one that I see is the y-intercept. Okay, and that's right here at 0, 1. So I can see there's a y-intercept at 0, 1. The x-intercept is happening somewhere here between -1 and -2. It's crossing, but I don't know the exact value by looking at the graph. If I had this open in Desmos, I could simply click on that point and it would tell me what it is as a decimal, right? Or algebraically, I could plug in a 0 in the equation for y and solve this for x. Okay, I'd add the 3 over to the other side, divide the 2 over, okay, square this side to get rid of the square root, and then subtract the 4 over. So I could solve this algebraically, but it's not that important right now. I don't think you're going to have one asking you for an intercept that's a decimal like that, so we're not going to worry about it. All right, so hopefully this warm-up kind of refreshed you on yesterday's lesson. Okay, this was what we learned yesterday, because what we're going to do now, before we jump into today's notes, we are going to do an FA over yesterday's notes. Okay, so FA, remember, that's our formative assessment. So you're going to go log into Aware, and you are going to look for it says, let me make sure what the title is. Okay, it's called the Unit 8 FA1, and it says graphing/key features. But make sure you're clicking on the Unit A FA1. Unit 8 FA1. Okay, it is 4 questions. I'm going to set a timer for about 7 or 8 minutes. Okay, and that you should be able to complete it then. I have the settings to where once you finish, you can immediately see your results and see how you did. So once you finish answering and submit, go to the My Scores tab and pull it up and see what you got right and wrong. And then we'll go over questions when you're done. Okay? All right, so I'm going to go ahead and set that timer. You'll go ahead and start on that FA as soon as you get there in Aware.